cosmic particles striking our atmosphere. They made a sign of this stuff, and they sound exactly like bird songs and bird chirping and stuff like that. So the birds are reflecting what they're hearing from in the atmosphere from the cosmic particles. Another term I'd like to change. Thank you. Well, particles, yeah, I'd like to change that term because it's a false solidness idea, which supports these atom packing or energy packets that Einstein brought into being that is suggestion of solidness, which is a made-up idea that's separating our cosmic charge into our realities. Because
have you heard of the birds? You can take successive generations of birds away from their original songs and teach them all brand new songs, generation after generation, and then all of a sudden, a few generations down, without being introduced to any of the music of its own internal knowing or songs, it will actually go back to the sounds that they make naturally and instinctually. And that is unexplained, so that's kind of weird.
Well, regression in evolutionary terms is not unknown, but bird brains apparently have more neurons in their brain than humans, so apparently they're smarter than us. So
okay, fair enough.
Well, it doesn't mean they're smarter. It just means that they're more dense. But yeah, I listened to the NPR thing about it as well. If you caught it there, but yeah, that's where I caught it.
Yeah, we are talking about terms, and yeah, I would like to change the idea of particles and atoms and stuff like that, because we need to go back to waves. We're going to need to go back to Maxwell waves and fields. And if quantum is necessary or desirable to have, then they need to input cosmic charge directly into it rather than an electron. So that's my idea.
I agree, and I think mainstream science is definitely already going in that direction, or some avenues of mainstream science is already headed in that direction, using twistors and Hopf vibrations. Those are all Maxwell equations, and they're all exponential. And not to mention they're all also topological transformations, and which is what we talk about, homeomorphisms, changing a donut into a cup to drink out of, back into a donut or something else. Those are homeomorphisms, and that's what plasma likes to do on the regular.
Yeah, the more that we can change the...
Is that what we're talking about? Homeomorphisms? Like
plasma does it on the regular, constantly, from charge to charge, from structure to structure. It can inhabit one thing to another, one body to another, and just with changing of voltage or whatever is powering the plasmoid itself.
It's alive. It's alive.
Well, someone could argue that, sure. But
well, it acts as though it's alive, and it does things that really
yeah, so does fire,
wild,
because it's plasma.
Yeah, but the geometric view is and the terminology that they're using and the forms that they're suggesting gives us a better idea about this the waves and the fields and stuff like that that we need to focus on, and it definitely can help us to determine what the best terms would be for this phenomenon, so that we don't get trapped into limited ideas that keep charge out of the equation. Thank you.
Well, I can't argue with that on the whole. I mean, from what I'm seeing, dealing with understanding recursive patterns, and because obviously we have to recognize that. I mean, just looking at the some of the fantastic artwork from ancient cultures gives you the feeling that there were patterns and stuff happening. The roof of a synagogue or mosque or something, or some of those wonderful Tibetan structures with, or even from people from the, like even in the middle of the Atlantic Ocean in Tahiti, have images and such. So, and they do seem to have a pattern to them, like that they saw a pattern literally occurring. So we can't argue that these things can occur, because we even see it in the laboratory where we get these Alfvén waves have vibrations, and things that are stable suddenly become unstable. And how that happens is something that I kind of want to, I mean, James asked a few questions a couple shows ago about what do these terms mean, and I got it in my head that we should probably try to figure out, or at least help explain what some of these are, so that when we talk about them, kind of have an idea what we're talking about.
That's always a good idea.
But I still wanted to break the ice, allow people to talk today, and obviously we have a bunch of people on the stream who definitely deserve to be heard. So clearly, day's just starting. How is everyone doing in the day whatever quarantine?
Freaking wicked awesome.
Getting used to getting paid for staying home.
That's hardcore, isn't it?
Yeah. I mean, it's so hard getting so much stuff done and being so prolific and getting paid for just hanging out and writing my books, Hey, it's all right. Life is great.
Can't argue. I've tried to write a book. I've never succeeded, so power to you there.
Oh, every one of your episodes is a book. You just need to hit copy and paste. If there is a hearing impaired and you can pull it up, then there's a way that you could probably copy and paste the whole episode. There's a book. There's a book. There's a book.
Well, some of them are gems, but some of them aren't, and it's not always me. I mean, clearly, there are brilliant people who have showed some amazing work. I couldn't believe. I mean, still blown away by those star forts that we saw.
Oh my gosh. Yep. Still trying to get the jizz off my pants from that episode.
Yeah, we got to get Vin back here. He hasn't been around. Have you been in contact with him at all?
He sent me a few messages. But I've also another guy who was into quarks that I met at EU 2017 or 16. I can't remember which one. But Jim Reese, I wanted to talk to him because he had a really very clear or seemingly clear understanding of subatomics and something that seemed to unlock something. So I'm interested in that type of. I mean, to move from where we were at the Bohr model of electrons to where we are now, and that some of the principles that we use are, how do I say it? Like I was taught an incorrect way that doesn't exist anymore. like a defunct model, but that was still the basis of electrical engineering because we didn't need to know anything else. But to learn from someone who takes quantum, like someone like Edwin, and you begin to see what subatomic structures might be like, and of course then you start learning what they learn from quantum mechanics and the shape of the electron fields and stuff like that, and then you're wondering what the hell is an electron, that type of thing.
Yeah, that's what I would like to know from an electrical engineer point of view, or anybody else in physics. How do you explain transmutations? To make sense of it.
I can explain some of what I know. The limited understanding I know, as it comes down to the only type of one of the only types of transmutation I'm familiar with is cavitation and controlled cavitation, and that comes from a spiraling motion of a molecule turning into it's subatomic, and then it's ultimately it's the size of a molecule, the vortex that's produced, and like 1 micrometer or whatever. It's super small, and then once it hits a steel plate, just the air and the water can produce transmutation. So that could be happening constantly on the Earth without us even knowing it. Cavitation could be happening on inside the planet, and that's what the thermal vents are, and bubbles that are constantly coming up. But I don't know. So I think it's gyroscopic. I think transmutation is definitely gyroscopic.
Well, we know when water touches the surface of any kind, it removes charge from it. It removes electrons. It pulls electrons away from that surface. So that's basically transmutation right there.
Well, transmutation, let's understand what it is. It's changing one element
basically
into another
the beginning.
element. That's all it is.
Well, yeah, it's basically the beginnings of transmutation. It's taking electrons away from
the beginning of a chemical reaction.
Yeah. Well,
my understanding is that the bonding that they require for atoms and particles it's impossible without millions of degrees, and so without that's.
Go ahead. Sorry, I didn't mean to.
No, I'm just saying that if it's impossible, then what are the blocks that they put up that we have to remove in order for us to get to a system that actually functions?
Well, let me give you an example of this exact problem. They saw in a faraway planet, exoplanet, they saw water turning into hydrogen and oxygen. It was separated. Because electricity doesn't exist in their model, that process had to occur thermally, which means the temperature on that exoplanet must be 3,500 degrees for water to thermally break into two separate entities. But electrically, it requires about 9.5 volts. That's it. So when we're watching this type of thing, that's the type of problem that I'm seeing. And to accentuate that fact, one of the things that I see is that like I was saying, I'm not Edwin in the sense that his structured atom model, which I could go into because I understand it fairly well, but I would obviously not do him justice compared to what he knows, is basically a very good attempt, and I really mean this genuinely, not with any sarcasm, to understand the actual inner structure more than just numbers. more than just understanding that they're going in the order of protons, and then there was a difference of atomic masses and stuff like that, and then they begin to learn about isotopes and so on and so forth, and why do these things give off neutrons that decay into protons and electrons? Well, from what I'm seeing is that I've learned it, as I said, I've learned it wrong. So I'm not qualified to speak on the subatomic structure, although I have a lot of ideas, but I defer to people who would know it better than me. And even Dr. Donald Scott was probably taught a similar type of fashion to me, in the sense, I mean, obviously he's became a doctorate of it, so I'm not saying that he stayed there. But even the very first textbooks that he picked up in like Electrical Engineering 101 type of stuff, why does a magnet affect a wire? Why does what are these effects and were they discovered? And going through that process of the actual process that they learned how to discover these things, you go through very simple understandings of, and it becomes clear that you're basically playing with the real building blocks of materials, or of things that are invisible, you can't see them, but you know that when I do the numbers correctly and the math correctly, I can calculate exactly how much torque is on this when I do the math. And and that's because of the Lorentz force, which is coming across because of of the Faraday and all that, and learning it all way back to there. But they were playing with that as a material, as substances, before they even understood what electrons were. Even back then, electrons were cathode rays up until like all the way into like 1905 type stuff. So, I mean, I don't know exactly when the electron is, 1907, 1897, somewhere in that area, I don't know. But they didn't, I mean, even then, what did you really understand? I mean, now that we understand electrons as fields, like back then it was a plus charge and a minus charge, and they were doing all this on paper and graphing it. And they were doing graph by graph by graph. And this is where the misconceptions came in that turned into a huge problem for this conceptualization, because in that graph that you would draw for electrical engineering purposes, that's what they had. And when they tried to compare that to space, they would say, well, just by looking at it, it would ground out. So there's no such thing as voltage difference in space. That was their theory. Or, well, actually, their belief that they just basically tacked on there with absolutely no evidence whatsoever. So that is the problem, because when you started actually experimenting with it, which was besides Birkeland, Kristen Birkeland, no one did anything regarding this, really. I mean, there was Hans Alfvén, and that was it. A few people in Finland, a few people in Sweden, and then, of course, maybe the military, doing, what we would call things like the Philadelphia Project and inventing the first computers. But in that aspect, what they were learning they were using a principle of plasma, which is why vacuum tubes became essential. They were using a principle that we today have moved and made smaller and smaller. You've heard of the transistor radio. Well, a transistor radio is exactly like a vacuum tube. A transistor is a vacuum tube. They're the exact same thing. And the real term for, and this is probably going to be the first thing I'll cover because it's so incredibly important, is how it works. And I'll actually just explain it as clear as mud, hopefully. It has a transistor, more or less, and the principles inside of a vacuum tube are such that a vacuum tube will allow you to it's basically like a throttle to control power flow. So with a little change in the voltage or current inside the tube, oh, my alarm's going off, it's 3 o'clock. All right, so basically what happens is this tube will allow current to go through off a very small input signal. So this is how you have the input signal from an electric guitar goes into an amplifier. Literally, a tube amp will allow that input from your magnetic wobblings on the strings to be transmitted through the pickups, which I'm not exactly sure what they are. I think they're transducers or magnets. But anyway, rolls on down through that as a very low-powered signal, just using the intrinsic nature of the properties of electrical materials. Like, there's no input power required. You just spring the guitar, it vibrates, the vibration affects these signals, goes all the way through, down through the into the third input of your transistor, basically, and this vacuum tube. And when that wobbles, it allows and controls a lot more power through it. So it allows you to put the full current of the house through that amplifier, but it completely isolates the input power, which is the signal from the guitar. So when that goes in, the same thing occurs in a transistor radio. So in a transistor radio, we've all seen one, hopefully, if we're that old. And a radio signal is picked up, and it's very low power, but it vibrates this input. And as this input vibrates, it controls a lot bigger input, which is controlled by the battery to the speaker, which you hear. And that is a transistor radio. The only thing that requires you after that is a little tuning circuit to be put into it so you can change the channel. And that's it. That's all it is. It's like 3 components. So when you're looking at that and realizing what you have there and how that works, this is when Don Scott says something like the sun acts as a BJT or a bijunction transistor or a transistor, because the properties of the sun, and likely the Earth too, to some degree in all planets, is that there's a lot of power exchanging itself on the corona, but it's controlled, and therefore, as it goes up and down, depending on the input signal, you're controlling the output, which is basically how things go into balance. So this is where the cellular structure of plasma occurs, basically. And you start building up. Whenever you start building up these things, one of the things that most people don't know is one of these transistors, a strange thing can occur called, because you can have a very powerful, let's say you're controlling like 10 amps going through something, right? And you're just driving the current through this, well, probably at that point you're using a MOSFET, but I'm not going to get into the difference here. So the point is that there's lots of current going through, and you just change this current, and you're basically only running at like millivolts or milliamps, very small input currents. That's all you're really running. But it turns into big swings on the other end as this guitar is like going boom, and you hit the bass note, and now it has to control all this power going to that speaker. Well, as it does so, it's vibrating to the input that's going through it. But there's actually a slight delay that you don't even calculate. This is what I was talking about, odd things that occur, which is basically you build up capacitance between these 2 points, because there's actually a real big difference in voltage between, and they're very close together. So this is called stray capacitance. Well, this type of thing is, when I looked at all the, even though I don't know all the like as much as someone who knows the quarks and knows the subatomics, like I was saying, the principles of electrical engineering don't change no matter how big you get. And this is the problem. Just like when we go, it doesn't matter how small the objects are. 2 objects right beside each other are technically exerting a gravitational pull. And they'll say that with confidence. But the same thing is true for the principles of electrical engineering in regards to this. The charge of a body is not something that it just suddenly goes away, because you can't transmit that charge to another body. So yeah, they build up charge to each other, and we see evidence of that. And I think that because of that, this is where you start getting when you start looking at the transistor effect, that's where you start looking at in the atmosphere, updrafts and downdrafts are the beginning of Birkeland current footprints type of thing, or more importantly on the sun, sunspots, where there's a complete breakdown and they're basically just open. So you're instead of holding back that current, it's 100% free flow. Just go on out there. And it's basically like someone just turned the amp to full blast and just let her rip. And that's what it is. There's a big flow of current going out of that hole. But on the other places, there's a balance because there's a capacitance layer that is controlled by this BJT effect, which has to do with the entire voltage of the entire sun. So this is basically controlling most of the sun's surface, except for these sunspot areas where you get this breakdown, likely because of magnetic, as we talked about, magnetic folding and the reconnection between 2 points and stuff like that. Sprites are not necessarily an Earth spot. They're more like a breakdown point, James, between like, if you understand that there's like the best way to say it is that once these things start spiraling, as we talked about before, once you start getting a spiral going, you have a magnetic field, and the magnetic field is itself an energy storage device, just like a capacitor. A capacitor holds things like a spring does. So there's two amounts of pressure, and they're pushed against each other. And the physical pieces of metal, if they were unhinged from each other, would just float apart naturally, or slam together, depending on what, if it's a positive positive or negative positive. You know what I mean? So if there's a difference in charge and they're both positive, they'll fly away, and if they were a negative positive, they slam together. But the end of result is exactly the same. They are staying there because of a physical ability thing is holding them back. Basically the brace between them. In this case, we have a dielectric, which is the atmosphere, which is holding that whole thing. That's actually not holding the charge. That's the breakdown between them. That's where you have thunderstorms and sprites and everything like that. But something is holding that entire charge away from the Earth. Otherwise, it would be attracted to it. There's 500,000 volts there. It wants to connect. It wants to get down there, but it can't. So something inside of the Earth must be repelling it. The entirety of the charge inside the Earth, at whatever layer, and I happen to have this episode of See the Pattern up on my screen, even though I'm not sharing it to you guys, because it was talking about the different things inside the Earth, and one of them, of course, is exactly what is this charge layer? How far down is it? And it must be there. That's what is so important, and I cannot stress enough that the laws of electrical engineering do not stop just because things got big. And that's impossible to drive through a conventional astronomer's head. But because the ionosphere does not slam into the ground and we do not immediately short out, there must be something keeping it there. Just like on the sun has a corona that is 2,000 miles above the surface. Well, that means that there must be something inside the sun at a depth of God knows how much, likely deeper, because as you know, if you can envision, the density on the outside of the circle is less than the density on the inside of the circle, so more charge, but it wouldn't have to be as close to the surface. So it could be down like 750 miles or something. I don't know exactly, but this is probably why volcanoes affect weather patterns and stuff like this, because you're basically having these charged bodies or charged things popping up. And a volcano outside of the Earth itself, to me, is like a tornado or a hurricane. And they don't last long because they're going through an atmosphere. But these things on the ground are staying there forever because there's nothing to stop them from continually being heated and continually concentrating energy. So, well, concentrating power. They're storing energy because they have a magnetic field and obviously heat and so forth. I now can't quite understand what the original question is, but I hope that answers it. At least starts. So I've talked enough. What makes the Earth a capacitor? Okay. I guess I didn't talk enough. The Earth is a capacitor because of that fact, because there is an ionosphere that is in the sky and it doesn't slam into the Earth. So let's go and look at an image of that ionosphere, the capacitor. I'm sure someone must have done something like that. All right. No, well, just some. Yeah, I don't want to get into that. Like a bunch of stuff. Oh, that looks like something good from Arizona. Yeah, okay, good. So yeah, this basically gives an idea. So we don't know exactly how high the ionosphere is. It's a gap. We know it's thicker around the equator. That's where the Van Allen belts are. But the ionosphere is positive and the surface of the Earth is negative. So we count the surface of the Earth as 0. And so the difference between the center of the Earth to the surface, we do not know the charge difference there. We know the charge difference from the surface to the ionosphere is about 500,000 volts, depending. It can change. Obviously, like I said, this is an energy storage device, capacitor is. So it will store energy and will be able to withstand the pressure put upon it, depending on the structure that the Earth is made of and its ability to, and the atmosphere around it, and its ability to withstand breakdown, which is where you get thunderstorms and sprites and all that kind of thing. And that's what you have, basically, a breakdown between the surface and whatever. Now, the thing is that they're very right to point out that these plasmoids in the atmosphere, which are occurring at a higher altitude, because when you get really close to the Earth, it's very wet and there's a lot of molecular material. So basically there's wind, but to fully ionize material is not easy, if that's the word. You can sometimes see when you put dust and smoke in the air, it will make a connection and you'll get twisters and stuff like that. But if you're most times, you get those thin water spouts maybe, but you need a lot of ionized material to transfer more current through it. And the atmosphere repairs itself so quickly. I mean, a lightning strike can strike 15 times in the same little pathway, but once it's gone, it's gone. It's ephemeral. The pathway will seal itself because it's like a leaky capacitor. But the Earth doesn't do that. The Earth, I mean, once you've made a molten connection, it stays that way until the power is gone. So that's why these things on the Earth are much, I mean, the total amount of atmosphere on the Earth and all the action there should equal, more or less, the entire surface activity of all the volcanoes and all the water on Earth. It should be about equal, because this is just a transfer surface. Compare the Earth structure to man-made equipment. Storage capacity. God. Well, the thing is that the storage capacity is directly comparable to how far away the ionosphere is. So at the end of the day, then, the Earth's capacitance is variable. You're basically asking me how much capacitance can the Earth take before things are going to get ripped off of it. And that's not necessarily destroying it either. So the storage capacity of the Earth is pretty strong. Like I think that in times in the past, the ionosphere was well inside the atmosphere, like less than 10 kilometers. So the electrical stress that the Earth's surface was taking was extremely high. Like it was basically stressed quite highly. In some places, obviously, when plants came by, they blew chunks off of it, obviously, but not all the time. And That's why when some material fell, if it was a magnetic material, like it formed mountains, because magnetic material can, that's why you get those weird structures like lakes inside of a mountain. But when you're dealing with other things like the Sahara Desert, probably was just sand from Mars that eventually just fell down, or whenever the rings eventually gave way because the moon showed up. So,
notwithstanding the possible plasmoid that might be at the center of the Earth, that is a massive battery that holds amounts of charge that are almost unfathomable.
well, every volcano might be like that, and like every tornado or every storm, sorry, every hurricane, all that kind of thing is sort of like that. But you're not wrong to imagine, but it's not like a battery. A battery is a chemical storage device. It allows you to basically store energy through the purpose of basically chemical reactions. That's what basically, and you're allowed to draw it out by use of different metals, which is obviously 101 type.
It's a Z-pinch storage device, basically.
Well, no,
it's not even a device; it's a natural occurrence.
But I call it a device because this is what I'm looking at right here is like that. It's a device. This is how we would build a spherical capacitor. This is not unlike the Sapphire project.
Well, yeah, I understand the double layering and
Right.
the Earth's surface and conductivity between the double layers and shorts in between the double layers. But I'm saying, James was asking how much charge or how much energy could the Earth hold? And if there's a plasmoid at the center of the Earth, like I suspect there might be, then that's a lot of energy. I mean, a lot, very much.
Well, I don't know, and to be honest, I'm not sure. I don't think there's any sort of Faraday cage that is holding that in there, but there might be. And then this makes a big difference. If we have a Faraday cage-like effect around the plasmoid at the center, we're not getting as much of that magnetism that we normally would. That makes sense? So we would be basically protected from that. But we still have an overall magnetic field, and we have the magnetic field of every storm and all the wind and the ring currents of the jet streams and all that stuff. So all of those are themselves storage devices, not just because of the kinetic energy that's in them, but because of the magnetic fields that they have around them. And each of those store energy. Now, the way that even
right, and it would be, if it follows the rule of how Birkeland currents pinch down and how the heavier elements, the metals, go into the inner surface or inner area of the pinch. And if Earth is a pinch with a plasmoid, then the magma chamber would be basically made up of a lot of metals, and that might be that Faraday cage separating the inner layer of the surface from a number of outer layers from the surface, right? Like,
well, yeah, we don't know exactly.
More double layer.
Like the Earth could have been, like, I'm not even kidding here. The Earth could have been like, imagine like a much smaller sphere, and then a whole whack of stuff just get dumped on top of it until it was like a 1,000 kilometers bigger. That's viable thing to happen on an electric universe type model. Now, it would suck for the things that were there before, but it's not unfathomable. So, but what I'm saying is that I was going through the principles of how a magnetic field stores energy. So a battery stores it like chemically, like I said. The spring effect or the tension effect of the electric field. So basically, a capacitor stores energy via an electric field. And it's a pure electric field. It requires no magnetism, and it will store energy just by basically like putting pressure from an ocean, like right up against a glass, or a spring being just jammed with energy and ready to explode. And the principle behind that is so true that is how we, like, there's a circuit called an RC circuit, which is a resistive capacitive circuit. So you would put a resistor and a capacitor together. Now, if you were designing shocks for a car, that equation is exactly the same. So the shock is your resistor, and the capacitor is your spring. Okay, so you can adjust the ratio depending on the weight of the car and how much, how hard you're hitting bumps and so forth. And that is the same equation. So they use that type of thing to, for vehicles.
That's what they do in racing with very, very fine adjustments, because NASCAR and games like Grand Prix Legends, they allowed you to go in and change the bump and the rebound.
Yeah, that's basically changing the RC. Yeah. Well, except you could actually have a resistor that is not linear. So you can have a resist more in one direction and less in another, which is a different ballgame. But let's not dwell. So the point is, though, is that a capacitor then is basically just like a spring. So it stores energy like that. So if there is capacitive energy around the Earth and it's not slamming into it, it's being held aloft. Well, if it's being held aloft, it's being held aloft by charge on the inside equal to the magnitude of the charge on the outside, or at least equal in power, or at least capacitance. So the way that a magnetic field stores energy is that it will, as the charged particles twist through a material, so a current goes through, it will generate a magnetic field around it. And although the magnetic field does not flow, it has gradients. And these gradients are actually, although they just change the direction of the material, they do have the tendency to concentrate electric current and so forth. And obviously the advantage here is engines and motors and all the wonderful stuff that we get to do today. However, it stores energy more like a water wheel, where the current is going through it, and as long as that current continues, that water wheel has energy. It's stored in the inertia of the moving wheel, even though in reality a magnetic field does not move. It does not flow. The current is flowing, but still, hopefully the analogy basically gives you the idea that this water wheel then is somehow storing energy. And this also tells you how it works. Whereas a capacitor will basically change the polarity and push back, in a linear fashion up to, like, it will release its power, release its stored energy to compensate it. Basically what it does is it maintains whatever you had going on there before. So if it wants to be at zero, it will continue to sort of like push towards that. And this is where you get that spring effect that we were talking about with regards to cars. However, that's not so with a magnetic field. A magnetic field, when the water wheel is spinning, if you turned off the water wheel, or if you turned off the flow of water, this wheel will keep on spinning, if you understand. And that principle of keep on spinning is how inductors work. And they basically will store energy for a short period of time. And of course, when you get right down to it, that's how a computer works, a switching power supply. You would basically have an inductor and capacitor. They will let in a little bit of power. Once it will store it in these two devices. And then once the power starts to dip a little bit, it will let more power in. It does this like a million times a second. So no moving parts, obviously. But this type of thing is not unlike then when you can see how we manage it in a computer system. When these spheres of charged bodies interact with each other, they do it in very similar ways, where they will interact, they store energy, and they release it, to try to get back to an equilibrium point. And that depends on the electrical environment they're in, how much of the electric field around them is impinging upon them. For example, we talk about in the past what it must have been like if we were under Saturn's lovely gaze, and imagining then how much electrical stress was going on in the Earth. And consequently, for years thereafter, once that ended, today, we're still electrified from that event. And we are still trying to ground out. And it's been thousands of years. And we are going down. It's eventually, I think, we will likely change gravity again. But those tend to go in spurts, like we talked about. They go in steps. And we see these steps because these steps are just like the ones in the atmosphere. It doesn't go up evenly. There are stages of voltage change between these points, steps. It doesn't go evenly. Once it finds a layer, like for example, within so many miles of the Earth, the bottom of the clouds, for example, and they said the clouds are going further up. You know, why are the clouds getting further away from the ground? Well, if the same thing is true, then in the past, the clouds would be closer to the ground. So I can imagine why you would hide for your life if you saw a thunderstorm coming. You know, if the clouds were only like 300 feet above your head. You know, that would be terrifying because the lightning must be incredibly strong at 300 feet. You know, so this is the type of thing that I try to envision why they built like they did. You know, why would you build underneath a cliff? Was it because it was too sunny or too rainy? I don't think so. I think it was because we didn't want to die. You know? And I'm sorry again for just babbling on, but I hope these were the subjects I really wanted to cover, was those three, like the idea between a transistor and the way the sun might work, and a capacitor, how you store that energy. And it's important that no matter what we even understand about the nature of atoms and electrons and quarks, whatever they are, it doesn't matter, because these rules are as real as the laws of gravity. And they're impossible to ignore. They might change depending on, like we said, like, oh, could the rules of gravity change if we're in a different electrical environment? Could the material change? Well, yes. I'm not saying that they can't. I'm saying though that if you're putting such onus on some of these, you should really put onus on this stuff, because it doesn't change no matter how big the surface is. We just don't see the interactions beside the northern lights, or, you know, a few, you know, transient lunar phenomenon, or bright lights on Ceres, or comets. That's it. That's the only thing we really see, besides, like, you know, like when we fly out to see the outer planets. But that's it. And so we have no visualization to put it in context. You know, it's not there anymore.
Can I ask a Sapphire question quickly? I'm having a conversation with runs naked through the forest. We're talking about Sapphire and how its ability to generate power is going to be over 1,000% over the amount of wind power. How much amps does Sapphire use? Do you know that, Neil?
No.
When it's running at 80 watts?
Oh, well, if it's running at 80 watts, then I can back calculate it.
They said it was very small.
It
was,
yeah.
They started with a larger one, remember, and they reduced it.
Yeah, well, I would say, if I was a betting man, that the goal would be to strengthen the electric field and to reduce the magnetic field, which I think that's basically what they're doing. So they're basically increasing the voltage high, which would explain, I think, some of Buddy's experiments with just wood, when he was carving into wood with his high voltage machines, would attest that you get that pattern on the surface, because it doesn't evenly. It's going to have cells that develop, as we talked about, and then you're going to have sort of like trenches dug in, because you're now having parts that are ripped off and then they're depositing somewhere else. And while they go through this process, which is basically like magnetism right along the surface, where you start getting between two anode tufts if you know what I mean. Like if we're trying to look at the Sapphire at that level of magnitude, even though I'm probably not doing any justice to their work. So please bear with me on this. But the connection like that would be something that might cause some of the elements to transmute, and basically you're in a high electric field. We don't know. A lot of this stuff is not something that people experiment with. Once you build a capacitor bank, once it's served its purpose, you're done with it, if you know what I mean. Like no one goes and investigates the atmosphere inside of a capacitor bank after you discharged it. You know what I mean? And why would you? Because the experiment was over here in Peratt's lab, where he was dumping 1.3 million amps across 2.5 friggin' inches or whatever, and creating, amazing feats of plasmoids, But the capacitor banks inside of all that, when they discharged instantly, might have done something like the Sapphire project does, but on a flat surface. But the spherical aspect of it seems to be intrinsic to the process. That's something that I'm not sure if we can change it, because unlike planets, we can change the head of a Sapphire project, like say make a teardrop shaped. That might be better for the purposes of the experiment.
All I was getting at really was trying to, differentiate the amount of power that it takes to run Sapphire, as opposed to the amount of power that it takes to run a tokamak, which is probably mega amp,
yes,
right?
No, right. But you're not talking. What you're talking about is scaling up process. For example, well, you've heard about the homopolar motor, and you've seen how they make it with a few like paper clips and a battery and a magnet, and they sit around and make cats all mesmerized. Don't talk about. Okay, well
then the cats destroy it.
Well, yeah, sure, but the point is that you're looking at this thing spinning, and if you stuck your finger into that, you would not be worried about losing your finger. There's not any torque there, right?
Yeah, of course. Yeah.
Of course. Well, in that type of thing, we turn that effect that you're looking at, the real effect, that would have been something that Faraday looked at. Okay, that effect that you saw with the cat and everything like that, except that he would be using cardboard with salt water to make the electricity and shit. But let's not dwell. So, and a lodestone, okay, because he didn't have a magnet. But the end result is that he saw a torque, a slight torque, but a torque nonetheless, that was generated and allowed this thing to start spinning. This principle we turned into the Tesla car and electric motors that can literally lift up like a building. Okay, so we took that effect and turned it into that. So the effect of the Sapphire project is akin to that, if that makes sense. Once you have the effect, it's just a matter of doing it over and over again rapidly, or more power, or more spheres, or a wall of spheres, or whatever you need to do to make it to get it to produce whatever materials you want at whatever volume you require. That to me is the incredible be-all end-all. Now, if it comes to generating power, that's a different ballgame, because you're going to want to perhaps make it larger. If you're going, or maybe you realize too large, can't cool it, because one of those laser things there, that was like a nuclear fusion reactor, one of the newfangled ones, which was basically like two lasers pointing at one spot or something. I don't want to get into the dwelling of it, but if you look at the schematics, which I did, there's to cool it down, they actually pipe in water all the way inside of the actual nozzle itself that's getting hit with the laser practically. It's right beside it. Go all the way up and then come all the way back down at like 100 psi. And it comes out like steam, because it's cooling like thousands, like it basically has to get all the wattage of power from the heat away from that nozzle, and it has to do it very rapidly. So that's not something the Sapphire project is doing, but it's not something that a future engineering project might be able to do. Therefore, you could run at hotter temperatures longer and produce the effects that you want at higher currents without melting the tip, for example. These are examples of engineering solutions to problems that they might not even have, and probably have. They're probably going, yeah, that's really good for an amateur attempt there, Neil. You know, so these guys are pretty smart. So, you know, if you get my meaning.
We're all here to learn. Keep teaching, oh enlightened one.
Oh no,
Electrically enlightened one.
I have literally just went for 45 minutes answering the things that I've made sure that I talked about. And critically, it was important that, you know, we talk about this stuff so that you guys understand that these principles are not something that are well, this is why when Buddy says something, like Buddy is talking about the patterns, I want to see how the force is really transferred, right? I mean, the pattern exists. He's seen the pattern. We've, besides Gareth's show, see the pattern. But we've all seen these patterns. So to deny that the patterns exist is
asinine.
Fairly accurate, yes. So, but it doesn't mean that I have the ability to understand these vectored forces. There are people who are vectored specialists, like Dr. Constantine Mail, who also happens to be a person who loves the concept of broadcast power, which he tries to use with which he's apparently demonstrated. And of course, when we were in 2019, we saw it. So something like that. But you get my.
So what's your PhD thesis going to be?
I don't have a PhD thesis. This is all basic electrical engineering that you would learn.
I'm joking
literally.
with you.
Well, you know what I mean. But I'm trying to emphasize that the reason that this becomes something that's so, the electric universe becomes so compelling is because you're basically, when someone goes, it doesn't work that way, you know, in space, because of blah blah blah. I'm like, dude, I went to school for this to learn specifically how electrical fields work, and that rule doesn't change. There's no fall off distance. It's so what you're saying is BS. You know, you're basically telling me to ignore my training, which, by the way, powers the entire friggin' world. I'm not trying to say that it's right and that we have everything figured out, but we can still build an LED monitor, and you're watching on it right now. So, what are you expecting from me? You know, like, you're trying to tell me that this is a fallacy, dude. Do you know what you're talking about? I mean, this is the same principles to make this monitor are the same principles I'm telling you right now. There's nothing. All an LED is a light emitting diode, and all a diode is something that generates light when a forward voltage is applied, and it glows when that happens. A diode itself is not really what happens, obviously. A diode is basically, but it doesn't allow things to go in the opposite direction. It only allows voltage to go in one direction, so it's like a flow, but it sucks up a little bit of voltage doing it, and that therefore becomes a light emitting diode. And this screen is literally 1 million or billion, or actually 4 million of those. That's it, and they change color.
Hey Neil, Electric Origins had some stuff to say.
Please do. I feel like I've hogged too much stuff, but
so that's okay. There's plenty of other people that got stuff to say, and everybody's very much enjoying what you have to say, by the way.
Well, thank you.
EIC capacitor is misleading, he says. The reason for this is flawed concept is simple. The model disregards the non-uniform conductivity of the atmosphere, which requires the presence of a net positive charge in the lower atmosphere that equals the magnitude of the Earth's negative charge. The positive charge shields the action of the Earth's negative charge from polarizing the ionosphere positively. This, the lower D region ionosphere, remains electrically neutral, which makes the EIC concept inappropriate. What's your reaction to that?
I think he's, if I'm interpreting correctly, the theory of the ionosphere through conventional means is charged particles charging the ionosphere, and there is different layers, as I talked about, with regards to when you go up in voltage from the planet. I said, like, for example, there's a charge difference of so many volts per meter as you leave the planet, but then you hit the lower cloud layer, and now you're at a different cell. Well, in actuality, they're called cells, but the different layer of clouds is a different electrical potential in there, and there's more rarefied or ionized particles, and vice versa. There could be this; they could be electrically balanced, okay, but they are more ionized, so they could be equal in magnitude to each other. That's not what we're saying, but they will flow through that layer quicker from point to point. For example, they will head to a thunderstorm. The thunderstorm's electric field will change the flow around it, for example. And that's obviously, it is common knowledge that the electric field of a thunderstorm is obviously massive. But that still doesn't change. Now, I'm not sure his argument on where he was saying that for example, the neutral areas, or what he's trying to say that it's inappropriate. Perhaps I should go read it or try to read it, but I can find it here. Lower D read electrical. Yeah, see, like electric is neutral, but it's still charged. It doesn't have as many molecular pieces of it, though, but still more rarefied, thinner than, for example, the atmosphere below it. But what I'm saying is that there is this is not even something that could even be denied. We see this is actually described right here in See the Patterns video. If you somewhere further in, I'm not exactly sure, it was a conversation he had, if I can locate it. Yeah, we were talking about the S waves and P waves in the mantle, but there was also a particular layer which was found to be he was talking about here, I think. So could there be arcing going on inside the mantle at certain points at certain depths, which would indicate, again, a double layer, which again is what we are talking about with regards to the ionosphere. The ionosphere is basically just a low charge double layer compared to the sun. So this activity here, or the charge layer inside the Earth, which we can see, we know, well, they think it's moving iron, like we talked about, but they don't know why it's like it is and why it has isotopes different and so on. But this same action is what is predicted in the model, that there must be a layer in here of positive, which is literally pushing against the ionosphere up here to keep the ionosphere from slamming into the negatively charged Earth, because it will want to do that. Now, clearly, though, one of the little mysteries is that it's not a direct short across this 500,000 volts, because the storms themselves seem to spool up, and obviously, as we know, there's billions of volts that go through a lightning bolt, or well, maybe not billions, but millions, as it begins to work its way down towards the ground. So there are there seems to be, for example, Andy Hall goes into the thermopile effect, try to come up with an answer to some of these effects, which seems to be a good model for future research, if nothing else. But I hope I answered that question, because I don't want to give it any discredit, because obviously challenging the idea, because I'm literally just an electrical engineer. I see things the way through that lens, and when I see, concepts of a certain sort, I mean, literally, this is a if-then scenario to me, because that must be here because that is already out there. And if I do the formula and just write it out, it must be there, because I would know otherwise, because this energy would have to be therefore used. So the entire capacitance of the planet must therefore sort out. And the question also becomes, why is the surface itself negatively charged? And that's another
this
point.
yeah.
Go ahead. Sorry.
This reminds me that the scientific desire to explain an unknown by another unknown. We're flying around with assumptions about what the Earth is, and we don't know. And then we're trying to explain how the electrical system works, and we don't know.
Right.
I mean, this is really what is causing so much problems. I've looked at the Earth. It's 8,000 miles wide. The soundings of the earthquake data only go down 2,000 miles, and they say it diverts, and they don't really know how that really works.
And what is a shadow zone and all that stuff? Yeah.
And halfway down that, 1,000 miles below our feet, is where the moon is orbiting the Earth. That's the center of
gravity for the whole thing. Yeah.
Exactly. So the question, and the 2,000 miles soundings and the 1,000 mile gravity center of the moon are related. They want to, the astronomers want you to believe the Earth is solid, and that the center of gravity actually is the center of the Earth. But because of this mathematical model they can present to you, they can make a barycenter 1,000 miles below the Earth's surface.
Well, yeah,
but they're really what?
Go ahead.
Well, I'm just saying that they're pretending that they know that the Earth is solid, and even Velikovsky said it was either.
We're assuming that all planets are solid, except for apparently gas giants and the sun.
Yeah. Well, the latest stuff that we've got is that there's a cavity in there. Now, nobody knows what the cavity is, but it's not the same, and it's exactly at that 2,000 mark below our feet that this cavity starts, and it's a perfect circle in there, and that just doesn't happen by it's not a coincidence. And when you go only down 1,000 miles down below our feet, the magnetic fields actually point outward towards this to the atmosphere as a pyramid. It doesn't flow in that other direction. There's if you take out the equator and you make a pyramid exactly on top and go about 3,000 or 4,000 miles, I forget, it extends out to where the first Van Allen belt is.
Right. Okay.
That's where it ends. It points. It's a point. And so it's not this big circular round out and going in the outwards from us. It's going inwards from 45 degrees.
This is where I was saying the when you change something, like for example, let's say we if we had a higher electrical stress upon the Earth and the ionosphere was much closer to the ground, like we hypothesized earlier, well then the charge inside the Earth would also be pushed up and be much closer to the Earth, because it would basically be, okay, your charge is here, well, I must equal your charge. So I must, otherwise you're going to slam into the ground. So my charge must equal your charge, and this will be basically one of those tuning effects. And suddenly you're now, the whole Earth could be different. Right? Or, well, God knows what it could have done, is what I'm saying. I mean, we don't really know. Basically, a charge layer was moved much closer to the surface of the Earth. Now, if we put the Earth under electrical stress, basically its barrier that protects us is way thinner but stronger, if that makes sense. There's a lot more energy stored in it.
Yeah.
Because it's much smaller. The distance between the plates is much more narrow. But that happens because there's electrical pressure on the outside of it as well. But you remember, there must be something equaling that, otherwise she'll slam in, so there must be something pushing up against it on this side, and it must be equal and opposite, at least in electrical potential terms.
And that facilitates a lot of arcing and glow discharging as well.
Well, yeah, and God knows, I mean, it could have been the reason why it was easier to, carve the Grand Canyon or something, or stuff like that, because these charges were much closer to the surface. Now I'm literally hypothesizing here. And if there are people who are on the show who wish to challenge me, I am more than welcome for you to come on here and show that I'm wrong. But when I look at some of these things, these are why, when we look at them as electrical engineer, it's impossible not to, because I will do the equation for the power or the capacitance of the ionosphere to the ground, and then I would okay, since the air is not resisting it, because otherwise it could just slam into the ground, and it would discharge basically. Since it's not doing that, there must be something equal and opposite to it inside that is pushing away, and we happen to find something at the appropriate level. And that, again, is another, in my opinion, a sort of like a test. Now, the reason the surface might be negative, well, it could happen to very clearly to do with what's called the oh my God, I forgot the term. The skin effect. It's a term like, basically, if you're transmitting something down a wire, the outside of the wire will carry the majority of the current. So it'll get hot first. It will also tend to be negative because you have a ripple going along it. It pushes away electrons, or pushes away positive charges because they move slower. So this makes the skin, which is vibrating more, negatively charged on the overall body. We happen to know that there is a DC type of current going into the poles and stuff, and out along the elliptic, weather systems and so forth. But there also is a Schumann resonance, a resonance around the cavity of the Earth, between the atmosphere and the ionosphere. And it has a certain frequency, and this could be facilitating that type of effect. So, does this mean that why is the sun positive? I honestly do not know, because I'm not a doctorate of this yet. I don't know. It could also.
I think we should. I think we should try to understand these terms and the things that we do in fact know. Like the center of gravity is 1,000 miles below our feet. The magnetic field pinches at this about 3,000 or 4,000 miles away from that center of gravity, and that is where the first Van Allen belt is. Now the question is, obviously the ground on top that we're standing on is not as dense as what is down below us, but it only goes down to 1,000 miles, and then it reverses. It gets from dense to back to lighter on the inner side. Now that's like two magnets. Now you got on the opposite side of the Earth, you get the same thing. Now as basically you've got four magnets. They're spherically around. Is there a Faraday cage in the center, and basically four magnets, two on one side, on both sides? Could that reflect the magnetic fields that is coming from the Earth? Does that show that structure?
Well, the thing is that we're only beginning to even see the internal of the structures. Like before a certain period of time, like not even, I mean, let's just face it, I saw things in the 1980s that should have been removed in the 1960s because they were like not even talking about plate tectonics, but that's how old that stuff was. So here you are trying to learn, but plate tectonics was a new thing, but this came because we started seeing things from space. We had a different point of view. But before that, all we had were basically the what's it called, S waves and P waves from earthquakes, and then we had magnitudes. That's really all we had, and directions. And then we could back calculate and try to figure out things, as they happened. Now, of course, we can have real-time data and all this wonderful stuff, so we can do things literally 100 times or 1,000 times faster than they could just a few years ago. So kudos for us in this, to the data that we can accumulate. But it's the interpretation of the data that matters. So, because your theory will determine that. And that is also just part of the picture. If you were still a doctorate of geology, the chances of you learning anything that they have learned in even the field of oil drilling, where they've learned like about oil-eating bacteria and all this other wonderful stuff, like and crazy, stuff as we managed to tear apart an entire province. So in that aspect, you have to wait till they pass on almost, and the new generation who is familiar comes into this. And this is why we're here in the first place, because that's basically, we've now hit a point where we want to skip ahead. Like, can we get there now, please? We know you're going to get there because this is so obviously in the right direction that resisting it almost seems silly. Because I'm not even saying believe something new. I'm saying pick up a textbook and read the friggin' book, and then go back to geology. That's all I'm asking. And this is not changing. This book has been the same. Now, whatever the electrons are, whatever the structure of the atom is, however fusion is caused, none of that has anything to do with the fact that charges work this way, and we have found these ways to manipulate them. That's it. And, 1,000 watts will do this much. The energy is this powerful. It's an equation. It's almost a must-be situation. So, in fact, it is a must-be situation. I mean, it has to be there. And this is where we end up clashing heads, where you're like, well, an astronomer says this, and you're like, well, but it's in the electric field, and that's clearly an electrical event. How so? And they can't see it because they've never been trained in it. And you're like, but that's just a plasma gun. I mean, you can see the streamers coming off it. And they don't want to admit that's they think that's a volcano on the Io. And you will want to slap them. I mean, if they were, what your professor would say to you if you tried to say something as stupid as some of these friggin' astronomers. And I'm not trying to be mean to astronomers. It's not their field. But if you said, if I went to my engineering professor and said, well, you see, the discharge current between the capacitor or the discharge current of this capacitor, because it has the resistor in it, this is how I would explain it, right, in engineering terms. And that's the rate of discharge, okay? And I would put that in the equation. If I went to him and said, okay, the electron rain that is falling onto this plate from the other plate will stop raining at this time. If I said that and put that on a test, he'd laugh me right. I don't know. I think they'd just tell me to get the hell out of the school. Like, that's ridiculous. You can't write that down. That's preposterous. And that's what it feels like when someone says electron rain to you. or solar wind because it's ridiculous. You know what I mean? It just it causes internal laughter or pain here, you know.
The movie Dumb and Dumber comes to mind.
Yeah, and you don't want to be that way because I don't want to badmouth them because they're doing a lot of good work. It's just you're not lying when you say you should really look at a textbook on electrical engineering 101, you know, just take a peek.
Yeah, this goes back to the herd dynamic, and particularly in organizations. We all know it's obvious that the textbooks are just full of crap.
Well,
And we no.
You mean astronomy textbooks, or which textbooks are we referring to? Because I believe in learning.
Anything. Yeah, well, I do too, but I'm sorry. The textbooks that they have, you can't. They don't work. You can't even. They're so full of stuff that you could misinterpret, or even just to follow the instruction. You can't even follow their instructions. And the technique that they're basically teaching you is that no matter what result they get, the authority is correct. That's the thing that they're trying to teach.
Well, maybe in certain things, but when I'm going with a technical school, and I'm just being honest here, the rules, for example, of maintaining a building and not having it fall over, or a bridge or something, are pretty sacrosanct. The rules of making an engine work, anything like that, a motor for electrical motor, if I was doing that, or a generator, any of these are all real things that really work. And obviously in that sense, I think that, but when you're probably right, when you're going into things like meteorology even, you're sitting there going, okay, why can't we predict more than maybe a week in advance with any certainty? Because our theory is wrong. But they don't want to say that. And don't get me wrong, it comes from a long line of observe and report from almanacs and everything else for friggin' years. So I'm not trying to diss that. But if no one tells you that these things, I mean, if we could put these into the models, I mean, with the power of computers today, I mean, with literally you can buy AI cores, tensor cores on video cards now. So, and I just saw a version of RTX which is what the technology is called, which they said, oh, this is amazing, but what can we use it for? And one of them was amazingly, I couldn't believe this, I was listening to it myself. It was noise cancellation, but he was like, okay, I'm going to try to speak, and I got my kids in the background screaming. Literally, he got them screaming. And he was talking like he was really loud, like, can you hear me? I am speaking. And he was perfect. You couldn't even hear the kids in the background. It was instantly removing them completely from the equation. And that type of, some of the people were trying to actually break it, like bring over multiple fans that are completely overwhelming the voice of the speaker, completely to the point of you couldn't function, like 120 decibels, and it was still possible to hear him talk as if those things were not present in the room. Now that ability to do that live, real time, and that's the type of computing power which you could use in meteorology if you understood magnetic and electric fields were part of the equation. You get my meaning? You know what I mean? That's
yeah, I do. But the filter is still the leadership accepting reality. And I mean, what you're saying that this has to occur, and it doesn't. Because herd dynamics is, and particularly in organizations, is not anywhere near what people think. I mean, this happened in engineering in the Soviet Union to the point where they said the engineer has to be standing below the bridge when the train goes over, because when it falls, the bridge falls down, he has to die with it if he screws up. That's how bad it got.
Yeah,
and I'm
that
saying
also went into their. I mean, I recall a story about the what it was like at the early part of the the Leninist Revolution up into the 1940s and 50s. they were still, like, the police were still thinking in terms of witchcraft. You know, like, that was a viable thing. You know, like, that, like, forensics wasn't a thing. Like, how could you solve crimes if you don't even know how to do that, you know? So, you know.
Yeah, and that is, you know, reality is not necessarily a basis for leadership changing their ideas. We're not going to change the astrophysicist guys.
Not until the consequences of their actions are apparent. Like, that's one good thing about engineering. You know, when it falls down, the guys die, it becomes quite clear he was wrong. You know, and you know that, right? If you build something and it doesn't work, you're wrong. You know, it's really easy, right?
Well, you know, but they still built them so that they fell down. But like I said, until they made them, as you say, consequences. But that's the problem. The astrophysics guys don't have any consequences, and they are not going to change until other consequences like budgets become the reality.
Well, I think you're not wrong on that. I mean, even when they you know, plowed a freaking orbiter right into Mars, I mean, that was just considered a design problem. It wasn't a failure of theory or anything. The space shuttle exploding on the way in 2002, discovery there, that could have been it, but they denied that the picture exists. So it's not part of the equation. It's just, there was too much friction because of the heat, and the wing blew off. You know, well, sure, but really? Because if you were a forensic person and went through that, I'm sure you would find there was high current burn marks going through that. You know what I mean? Like, it's that type of stuff, and then of course being hidden away. You know, like, and I don't mean hidden, but you know, that's a consequence of failure of theory, because that's not their theory is resist the heat coming in. Well, yeah, but you're also plowing through 500,000 volts at Mach 25. You know, like, that's not safe in a metal object. Just letting you know. Just if that's if that's not appropriate to think about, let me just fill you in. That's not how you should do that. You know, like, you should.
How thick is the casing?
Yeah, how's your Faraday cage holding up? Because that's all that really matters. You know, like, because they're trying to resist the heat that is caused by this effect that we were just describing. The capacitance builds up right on the front of this thing because all the molecules rush to this plane, this thing that's entering into the atmosphere. The ions
That's what's happening in tokamak. Yeah. That's exactly what's happening in tokamak. It rushes to a point on the wall of the chamber and tries to eat through it.
Yes, because
30 seconds into its running, because it's based on a wrong model of the sun, the atomic model.
Well, and they think that plasma can go in sheets automatically, but like you said, when you go into that BJT area that we talked about, that's when everything goes to literal crap. Like, you suddenly get fluctuations everywhere, and suddenly signals are because they're interfering with each other. Everything goes nuts. And then when the power is drained, it will suddenly calm down again. And that's probably what they saw in the sky when they thought, like, Valkyries were coming from the heavens and crap like that. You know, like, I mean, yeah, skies are on fire, Valkyries are coming, they're killing people, you know, and you would just accept that or whatever, because you would see it happening.
Run away, run away.
But then it would calm down again, the balance would be restored, everything would be chill.
Monty Python comes to mind.
Oh yes, definitely. But that's what I'm looking at when I see some of these type of things.
So you're telling me that the airlines have a better forensics than NASA does, and with that in mind, in the structure of the Earth,
I mean, that picture just wasn't published. I'm sure NASA is just not telling us, and I'm not saying that they're trying to be, you know, they're just sort of like being intentionally vague as opposed to being lying. But maybe the
leadership.
Go ahead. Sorry.
Isn't it not the leadership that's making those decisions?
Yes, not the scientists.
Yeah,
who
of course. Yeah, it's the leadership are saying, well, we're just gonna not talk about this aspect.
Or of course,
stay away from that.
Nobody wants to look bad, right, you know, or incompetent. But going back to the structure of the Earth, is there a possibility of Faraday cage inside of it?
Well, a Faraday cage is basically just an encompassing of metal, right? So if we assume, and I'm not assuming this, but let's just assume that on top of the continents are just rocky outcroppings like a crust, and that the ocean bottom, which is mostly basalt, so mostly iron, is then covering everything underneath, then Earth is basically just a metal ball with some crusty parts on top, which is the continents. So in that case, if that is true, then everything inside of that, we would have to try to figure out what's there, and it would be seen through a Faraday cage, basically. So what can we find, and how far can we go down? And what do we find when we do that? These are things that were explored in this video here with, again, see the pattern. But I don't know for sure what's really going on down there. But it would not surprise me because if that's true, then yes, there's a
heavier and heavier metals as you go further into the crust, and well, beyond the crust, I mean, into the mantle. Heavier and heavier metals, layers of them.
Well, actually, that's not what would help, though. It's not the heavier metals. Lead doesn't.
Combined with silicon, of course.
No.
Because you're mostly silicon, right?
No. What I'm trying to say is, it's silicates, and they're on top in the crust area. Yeah. But the basalt is more iron-based, and iron's the key here, not metals. Heavy metals are good at radiation shielding, but ferrous metals.
Well, when I say heavy metals, I meant metals in general, just metals. I didn't mean heavy atomic metals. So.
Well, what I meant, though, is that the ferrous metals,
as opposed to hydrogen and oxygen and so on.
The ferrous metals are the ones that create a Faraday cage. You know what I mean?
Roger, yeah.
I mean, Roger, obviously, you can get the electric effect inside a car, and yes, that can happen. But ideally, you would use because of the ability to magnetically pinch. Not necessary, but I was mostly going with the iron because of that reasoning, because it tends to concentrate magnetic fields. When we were talking about that before on earlier programs, musing aloud about the idea of the iron sun and maturing, like because of this type of effect. Like, what would happen if the effect of for example, if you took the Sapphire project, right, and put it into space, blew it up to the size of the sun, and then turned it on or whatever at a certain amount of power to it, well, if the entire surface cannot deal with it, it will melt. Okay, but it won't float away from the surface of the machine, so it will just stay there like a giant ocean of metal. But the actions of the different layers of this process would be shifting as it's dealing with different input characteristics from the wherever it's getting its power, likely from like we talk about the local chimney. So if you're dealing with that and it's coming in and it has to be concentrated, well, there will be layers of this going into the sun, and each one would be responding to, in the BJT-like effects and the transistor-like effects, basically moving up and down, and it would be melting at certain layers over other layers. So the idea of then continuing to cook until it's a lot of iron, because then it will begin to concentrate magnetic fields. That happens to be something that happens where the changeover occurs. All the processes towards the sun are, I guess, nuclear endothermic or exothermic, until iron, and then they take more power to make, and so it absorbs energy to make like heavy elements. You know what I mean? But splitting helium into hydrogen is a net energy bonus. Like it releases energy. Yeah, I mean, so this is where the idea of suddenly the sun sort of cooking till it's like, and stars, because they're focused for a while. Basically it's like imagining a million little lightning hits all over the entire surface, just changing the material into different material, just like it likely does on the Earth, but a lot slower.
Let's assume a different thing. Let's consider that the Earth has two shells. One's 1,000 miles deep down, and the other's another 1,000 miles. There's a cavity. We don't know what it is, but they're separate, and they're made mostly of oxygen, solid, and sand, and a few other things. Mostly, actually, magnesium and aluminum and whatnot.
Mm-hmm.
And let's just assume that the iron production is actually on the surface, both on the outside of the surface and on the inside of the surface.
Mm-hmm.
Is there a possibility of Faraday cage in that?
Well,
inside?
Well, that's what I would be thinking. If there was there's a possibility that the outer shell, what we call the outer core, actually it's more defined somewhere in the other picture of it. Yeah. So where the outer core is here, and you can't see it, but excuse me, it'll pop up on the screen here. If the outer core was right here, if it was, for example, liquid. Now they think that's wrong because it would have to be more dense as opposed to less dense. But in this idea, then the outer core would be liquid and the inner core would be the plasmoid. But if this is literally a molten sea that is, I don't know, 1,000 kilometers thick, there is no possible way that anything inside of that thing is getting out of that 1,000 kilometers of metal. It is completely encased in a Faraday cage.
Then how does it represent for them the magnetic field if it's completely enclosed? And that's 4,000 mile wide cavity.
Well, in the model, they think that this is spinning somehow, and this spinning is generating the magnetic field via a dynamo effect. And the reason that it must be there in their equation is because the must be states that the planet is so heavy it must be made of iron. That's basically it. But like I said, if the equations are variable, if these things are not standard, if gravity can change over time and other material properties can change over time, then well, then that's not a requirement. Basically, we do not know the composition of a body by its size and apparent angular velocity / mass calculated that way. That is no longer, if this interpretation is correct, that is no longer viable. Therefore, we can no longer tell what a body is made of until we actually probe it. I mean, or look at it or whatever.
It also assumes that you know what mass is, and that we both now know that
Exactly.
It's got nothing to do. It's got nothing to do with how big the shape is. It's actually how much charge it can hold. That's what really it's measuring.
Now, most importantly, I don't want to be dissing any of this stuff. I mean, I'm a big fan of specific gravity with regards to, which is basically density, in regards to and specific heat and all that stuff, because all of that stuff works perfectly fine on the Earth right now. Okay, so I'm not telling you, don't go into engineering. None of this matters. It could change tomorrow. You're right. It could change tomorrow. The electrical pressure of the planet could change. Not likely. Not likely at all. But that said, those rules are real on the Earth. I think our problem is, like as we talked about before, the assumption that these are universal laws. And some laws became universal and others were relegated to secondary effects that only occurred on the surfaces of planets, like electricity. If you get my meaning, like that's an engineering thing. It became an engineering thing. It was removed from astrophysics somehow, but it is not I mean, it is just like by calling the universal law of gravitation, well, as our mentality of what the universe was. And remember, he invented that thought in the, I don't know, 16 friggin' 50s. I don't know when that was. Okay, under a quarantine apparently. And as he did so, he, Sir Isaac Newton, like all he knew was the solar system and the stars. By the time Einstein had made his theories, the entire universe was only a galaxy, the Milky Way. There were no other galaxies. And now the universe is God knows how billion light years across, apparently. Well, we still call it the universal law of gravitation without ever testing it past the surface of the Earth. Get my meaning? That's the assumption that is just intrinsically put into the problem. If we called them the universal laws of Maxwell, maybe they would continue off onto the stars. That's the trick of the human mind. That is how stupid we are as intelligent monkeys. Sorry, but that's where we sit, and that it's kind of embarrassing when you think about it, that you could be led astray simply because we named something wrong.
Well, I mean, this again is the leadership dynamic, herd dynamic, holding on to, Chris Kelly said, what was the, advantage of the leadership to hold on to a lie? And I started thinking about it, and I think it's basically all about herd dynamics. They get to, like the mob, press you into making you hold on to their view no matter what. And I really don't know, why any leadership would, in science, hold on to these things. It doesn't seem that there's any really, financial advantage for them to hold on to a lie, other than they get to force people to squirm. That's the only thing I can come up with at the moment as to a particular advantage.
Well,
Thank you.
I think you might underestimate the desire to be right and the need to feed your own ego. Like, I'm not saying that these people are egoists or whatever, because obviously scientists do good work, and I'm not the type of person who wants to diss science. I hear a lot of people who want to diss Neil deGrasse Tyson. They want to diss Bill Nye. They want to diss the whole idea that everything about this pandemic is not correct or whatever. Well, I'm not saying don't think critically, but I'm saying the belief itself is the problem. Once you begin to believe that your way or the highway, the more you begin to close ranks. And as there was this probably has a lot to do with the overall structure of, for example, as churches had a lot of power, it was rebellious for the technical schools to teach the, obviously, engineering and so forth. And then because there was real value in that, people got to make better sawmills and so on and so forth. Well, you keep pushing along these lines to, you make better structures and everything, and that's a technical school. But the beliefs, basically the church was sort of like waning in a way. I mean, you don't really see, and to be fair, it's kind of like something that they were okay with, and I hate to say it this way, but like the Vatican's kind of chill in a lot of ways. I can't believe I'm saying this comparatively, but there has been an uptick, especially since I would say World War II-ish and afterwards, of fundamentalism. And that way, it doesn't matter what religion or whatever, but everything becomes much more rigid, and even science will fall victim because it will feel it's under attack, and it feels like it has to mock Bible thumpers or something. And I'm like, and for their point of view, they would say, well, these are completely incongruent thoughts. You cannot be a Bible thumper and a scientist or something. And I'm using that a derogatory term when I don't mean to be, but the end result is, though, is that there's a middle way. If you obviously look at Velikovsky and the stuff that we're studying here, that you can say, no, you can respect religion for maintaining or trying to maintain the truth for as long as it did. It was the first observational evidence, as it were. You know, that's like dissing the observational evidence of Faraday or Sir Isaac Newton because he noticed that apple fell. Okay, or he noticed Faraday noticed that the homopolar motor effect. Well, all that's wonderful, but these guys didn't have the language to even describe the crap that they saw, and they tried anyway. So in my mind, I go kudos to that. So that brings a level of respect to what you're looking at. So you can look at it and go, huh. But it also means that you have to look at things, from these things with a grain of salt. And if you could recognize that people try to force fundamental ideologies no matter what they're from, and if you can understand them as philosophies, take a step back and recognize that philosophies are good and ideologies are just belief structures that are automatically wrong. I mean, don't get me wrong, there can be an ideology in your mind that seems to be going great, but it's probably not for everybody. You know what I mean? So you have to be a realist, basically, and you have to see some principles. I mean, if science had one principle and stuck with that principle, we would never have gotten anything done. Science has a ton of principles that are generally true in certain situations. And that should be the same with philosophies or with ideology. You can pick and choose and go, well, shouldn't it be good to restrict on this one? Oh, yeah, okay. Shouldn't it be good to assist on this one? Oh, okay. Yeah. You know what I mean? Like, that's to me a more thoughtful way, one that deals with real situations. It doesn't matter what you label it, because, I mean, literally, sometimes labels are just scare tactics for people who don't know any better. I mean, you don't need to be scared of that shit. I agree with that. I mean, it doesn't mean that I won't challenge you, but I'm welcome. Anyone should be able to come up and debate these things and say, well, what if this? What if that? And I openly involve people. I want people to be involved in that. I don't want them to think that this is somehow above them or beyond them or something that they have to basically turn off their brain and just go, I believe in everything that you say. Well, no, you've missed it all completely if you believe me. Like, you shouldn't be believing me, because I will say things that are wrong, because I make mistakes. Just human.
So I think
the idea of the working model, I think, is really important.
Yeah.
We have working models in our head that we're kind of perpetuating an idea or, throwing alternate ideas against the wall to see what sticks. These are all, this is a process of discovery that we're engaged in. And I think, what you're saying is really, really important, that we can't be so married to our sort of way of thinking that we can't, that we're not open to, change. Michael Moore just put out a video about wind power and solar power, and it completely crushed the viability of either one of those sources as a long-term solution to our energy problems. And in doing this, he crushed the current sort of paradigm and went against all of the sort of assumed knowledge and logic about what sort of a whole group of our culture believes. And it was a really powerful thing that he did, and it demonstrates the idea of how important it is to have multiple facets on an idea. Each of us is a facet on a form, on a crystalline structure, Yeah. And each of those facets connects, but they're all different. And each facet has its own contribution to make, but that doesn't mean the facet is the truth. The facet is an aspect.
We talked about censoring something the other day, and I was like, no, because I don't want to be the guardian of that. You know, I don't want to be the guardian of truth. You know, I want people to feel very comfortable in expressing a different point of view. You know, with regards to the general idea that the universe and plasma is, you know, electric universe and plasma being part of it, you know, charged bodies in space type of thing. But besides that, the general, hey, that general statement is all I need to bridge common ground on this subject. Because obviously, there are plenty of people that I do not agree with in the electric universe community. And there are plenty that I do agree with. And I don't think that my ideas, I mean, I've learned from almost all of them, and being able to take a step back and seeing and going, okay, well, you know, this is kind of powerful. This is a new way of looking at it. This is, you know, and to wrap your brain around some of these effects is not easy. And especially when you start seeing things like what Buddy does when he and Heather, when she was on before, we were talking about the resonance of planets. Same with Tess. We're trying to understand how can these things seem to affect life. You know, how can they affect the way that we live? Do they? Is this just something in our heads? Is it something that we've programmed over the generations? Is it a vestige or vestigial reminder from the past? Or is it a real tangible effect that is not carried along by our species and inside our brains, but something that is transferred, and we react this way because it's a real thing directly affecting us, you know? And these are different understandings of the same thing. Like, and basically what I'm talking about is sort of almost like a ESP like thing, you know, but that doesn't mean that I have to believe any one of those theories, because I honestly don't know. But
Right.
I'm fascinated by the possibility and some of either intuitive knowledge.
We're all just trying to make sense of it.
Yeah. Yes. Sean, you had something.
Very well said, Neil.
Thank you.
Before you go, yeah, that was great. Duff, mentioning Michael Moore, I went to his YouTube page and dropped a link on Sapphire on them and their group over there.
Excellent.
So
Excellent.
hopefully you might do the same if you haven't done that already.
Just for fun.
Here, are you out of ideas? Here's one.
I did it on the 1.5 hour
brilliant.
movie thing that he had.
Bravo. I want to praise the shit out of you for doing that. That's amazing. Well, this really goes back to, I think, a bigger sort of experience that we're all having, which is our paradigms are collapsing and our sacred cows are all dying. And it's time for us to sort of adopt a new paradigm. And guess what? We just happen to have a new paradigm. So for all of our flaws, for all of our conflicts and inabilities to sort of cope with the enormity of what we're trying to wrap our brains about around here, there is actually hope, because change is in the air, and change is what we need in order to sort of establish a new way of looking at the universe, a new way of looking at energy, a new way of looking at our own health, a new way of looking at how the universe functions. And that's really, 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 really exciting work. And honestly, worth putting up with you guys for, because because it's that big. It's that big. What we're talking about, the conversation that we have every Sunday, is literally bigger than us, literally bigger than us. And I think it's important that we all remain in a state of, Neil shows us how to remain in a state of humility. Neil is one of the most brilliant men I've ever met. He's also one of the most humble men I've ever met. Certainly more humble than me.
Way too kind. My friends call me an arrogant asshole.
It's true. It's true. It's true. No, well, I mean, I'm not saying you don't have teeth. Listen, I know you've got a few defenses up your sleeve, but you are a pure of heart, and I think that is what carries us forward. I think it has to be about what is good, and we have to be willing to argue. We have to be willing to disagree. We have to be willing to lock horns, and it has to not be about us personally, because there's something bigger we're all trying to attain here.
Yes, and I find that we've had so many great people who have who've wanted to be, who we've had on the show. We obviously have people who have conflicted with us, and from other people's shows who have come over to state their disagreements loudly. But
Yeah, we don't
not
have to
pointing to
tolerate
anyone.
that. You know,
but,
we don't have to say everybody gets to say shit just because they got such say. The bottom line is some people say stupid shit, and that stupid shit is still stupid shit. And I'm not willing to not call a spade a spade. I mean, you know, the bottom line is if you come around talking trash, you're gonna get pushback, and you know that's the teeth part, isn't it?
Right, but at the same time, for anyone who wants to basically accept that you can have a conversation as a civil human being as if someone else is in the room and that you might get punched if you said the wrong thing, and I only mean that in the sense that you would actually act like if I met you, I would be acting the same way, is what I'm saying. Physically, I'd probably just hug you. You know, besides that moment,
the power of the hug,
and the handshake. You know, but other than that, there's no. I would be saying the same things because I do have respect for you, and I have respect for everyone here. And I'll tell you, none of you have said things to me 100% that I 100% agreed with. And I've never gone, get the hell out of here. Because it's not for me to, I'm not so fragile that I can't be wrong. There's some things I would like to go to the toe on. You know, like when we talk about, like, you know, someone will say something and I'm like, I want to, you know, it jumps me out of my skin. But those are things because we're educated that way. And these are like the intricacies of our knowledge. But that doesn't mean that, and if you go, well, there's a reason why you're not right in this particular instance, and let me show you why. I would be like, okay, because I can't know everything.
That's exactly what we need. The leaderships of all our, the astrophysics guys getting together with everybody else.
Yes.
Say, okay, your principle here, that doesn't work. You got to get rid of that. We have to get some pressure on the leaderships to say, no, you can't have that. That doesn't work. That's,
But they spent 150 years or more doing this to set it up so they don't have to.
Well, they fragmented. They've all fragmented.
Well, yes, and they destroyed the viability of natural philosophy right along. Like, I mean, it's basically the idea of what is the universe, and that was like, oh no, we're going to put that into the realm of cosmology. But why do they get to choose? Who gave them that? Like, I don't mean to be wrong, but who gave these people that? Like, who got that? Who went and said, okay, this is your realm. You get to tell us everything now.
Who died and put them in charge?
Well, literally, yeah. And I'm not trying to be rude, but shouldn't, like, the philosophers be the one that do this? Like, isn't that the people who should do this? You know, like, am I full of crap on that? Shouldn't someone who is, you know, sort of like a part poet, part someone who could condense this into a logical conclusion, but, you know, I don't know. It just doesn't seem right to have that put into the realm of people who are constantly surprised. Seems wrong, you know?
Yeah.
And
well,
again, not to diss astronomers.
Everything I was going to say earlier, guys, everything that Neil was saying the whole time gets back to the old classic, you know, psychological end of it, which is the appeal to authority, the argument from authority.
mm-hmm.
The description for the people in the listening audience is insisting that a claim is true simply because a valid authority or expert of the issue said it was true without any other supporting evidence offered. Done.
Mm-hmm. Yeah.
Argumentum ad
nice.
Veracundium. And it's like everything Neil was saying. Well, we know gravity works this way, but you don't know it works this way everywhere. No, we say it does that. Then what are you talking about, guys? Yeah, it's just.
Well, yeah.
That's the problem with people. Then the ego comes into play. Then the ego just kicks in like, no, Neil. I mean, I would say yes. All challengers come and be welcome. Come into this forum and let's talk about it. Absolutely. But then the ego gets in the way. People can post this stuff and argue it that way. But come on, you know, let's get real. So the authority says it's true. It's true. And if somebody opposes it, then, you know, here comes the sledgehammer. Like
Well,
on a guy like Velikovsky on up. Here comes a sledgehammer.
exactly.
No.
And they can't.
What
and
do you mean?
They can't hang people anymore or burn them at the stake, so they do this, and that's and or the popular argument is another one too, and that's also equally invalid. But it like you said, the arguments become where the consequences end. Like if the consequences are you're wrong and it's obvious, and this work is not getting done because you're wrong, this is you're wrong. Let's go fix that. But what the intricacies of planets and the arrogance to think that we can know everything when we really have never even sampled anything below like 9 kilometers or something, and we have never.
And Underwater Panther adds job security plays a big part in all of this. Go ahead, sorry.
That's true. And but it didn't used to be this way. Before they pulled ranks, there was this idea, like Sir Fred Hoyle talks about in that video called The Universe Cosmology Quest. I believe in one part of it he says that the problem was the American graduate system, and that the best way to get ahead when he was a student was to thumb your nose at the professor and prove them wrong. That would be the way that you would advance, because you're proving them wrong. Or, and that's the way that science is meant to go. But now it's sort of like, okay, get the book, and they just tell you. And then, there's no question. And even in my experience, they certainly did not go over atoms and molecules any more advanced than I learned in, 11-1 chemistry or something. However, that said, the principles that ended up being something that we rely on for everything in the entire world, which, electronics and electric and all that stuff, well, that is an incredible type of situation where you're like, okay, clearly these ideas, but this is where we couldn't see it. We're playing with something we can't see. And so we started going deeper and deeper into the subatomics with experiment after experiment, trying to figure out what's going on down there. And we started losing it once we start losing our scale, as it were. It's too small, we don't understand. And it gets too big and we don't understand. And I'm thinking that the exact same problem is occurring on both ends, if you know what I mean. It's basically your theory is diverging from things that we know into the speculative, and you're basically losing your grounding. You're losing the fundamental idea of what is real, almost.
Well, I mean, Neil, you said it earlier. I mean, with engineering, if something falls on top of the person who designed it, it doesn't work. It's even more common in chemicals. We know how flammable chemicals work and corrosives work and oxidizers work, yes, and can warn you against it at any point in time. Don't mix this with this, don't do this, don't do that. This can cause harm to your skin. A safety data sheet tells you that's exact empirical science, perfectly exact, all the time, repeatable over and over and over and over again. Then it just gets to a point, we talk about electrical engineering, but beyond the practical, that's when it becomes speculative, and people are just like, no.
Actually, I could give you a perfect example.
I say it works that way, but because it works that way, because I said it works that way.
But I'll give you the perfect example of where your safety data sheet, when you look at something like that, all of that, for example, all of that has to do with at ground level, at sea level. The moment you, for example, if you were looking, this substance boils at 108 degrees. The moment you go to 5,000 feet, that's like suddenly now 92 degrees. It boils a lot sooner. So these are things that, and the further we get away from things that we consider normal, the more our brains are no longer programmed to handle it. I mean, when they first got into what was his name? That guy from Canada, the astronaut. He was like, "What does space smell like?" It smells like burnt meat. That's what space smells like. Now, his thoughts were that this is all sort of like the smell of material that was stuck to the spacecraft. and that has sort of come off from the welding process and stuff like that. But in actuality, they have no idea where this smell comes from, or there's nothing to test. But your nose can smell it because we have noses. But
the same way, Neil. The magnetosphere is hot. It's hotter than the temperatures we're used to on Earth. That easily and simply like, hey, whoa, yeah. Like, whoa, wait a minute. Why is that? Oh, but all of a sudden, then it gets really, really cold. Allegedly.
But also, by the way, like we've
really
said before,
cold then. If there's radiation out there and it'll kill you.
Well, exactly, because that's synchrotron radiation, right? But when you're looking at, for example, the thermosphere is 1500 degrees, but there's really no atmosphere up there. So even though it's 1500 degrees, it's not emitting 1500 degrees in all directions. Thermally, it's 1500 degrees. So that's how fast the molecules are moving randomly. Bouncing off each other. But there's so few molecules there that the heat is actually kind of low. There's not a lot of, it can't transfer a lot of heat from your body if you were there, because there's not a lot of atmosphere to do it. It's still 1500 quote unquote degrees, but the amount of energy it can remove from you is low because it has a low, what's called specific heat. So that's what you use for like when you're using a space heater, or not space heater, but like inside of a water heater, and there's a coil inside that you push, and you're trying to heat up that area. Well, if you are transferring from fluid to fluid, for example, then one fluid goes into a thing and it transfers into this fluid, but it's using just a metal radiator or something. Well, the coefficient between these 2 points, blah, 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 the delta T of the temperature, yada, yada, yada. The end result there being is how fast energy will transfer across that. Well, if you put a near vacuum through that pipe, and it's 1500 degrees though, but it's almost a pure vacuum, that water is never going to heat up, because there's not enough heat coming from those bouncing particles. Even though they're bouncing really hard, there's just not enough of them to heat up that coil, to heat up that water. See what I mean?
Right.
And that's something that happens when people like mentally don't understand what they're talking about. When you're like, I've heard a lot of people on the Electric Universe forum, and I'm not naming names because I honestly don't know. I can't remember, but more than one person's like screaming, it's 1500 degrees in the thermosphere and we're not feeling it. How is a spaceship going through this? You're gonna die.
Oh my.
It's not an oven, buddy. Like the guy in the spacesuit's gonna be fine. Just relax,
Where everything's swirling up in the still in those layers as we go up anyway. So there you go.
Well, yeah,
space weather, it's not like, oh, it's 1500 degrees here, because Mount Everest is really cold. And then, we see that the climate of our planet on the surface, sure, but it's not there. What you just said is funny. We're going to die.
Well, yeah, but if it was 4 degrees on the top of Mount Everest, right, and it would be still fairly cold, because there'd be all your heat would be trying to leave your body, but the wind wouldn't be nearly as strong because it's thinner, right? But it's still not going to be, it's not like space. But if it was 4 degrees in the bottom of the ocean, it's going to suck the heat right out of you. Although, admittedly, you can't, the amount of surface touching you would be the same at the surface or not, but there should be a lot of pressure, I guess, but still. You get the idea.
Right.
And
I get the idea.
It's these little principles that are, like when you're talking about thermodynamics, when Pierre Robitaille talks about this kind of thing, about thermodynamics of the sun and how it violates, certain gas laws, I listen to him, and I learn from him, because he's speaking my language, but above my pay grade. So I'm like, okay, I can understand where you're coming from, and this is complex, but I'm following you. But when I see what he's talking about, this violates gas laws. You see here, here, and here, and I'm like, okay, I'm beginning to understand. But again, I'm where you guys all are when you talk about someone like him. I wouldn't say exactly, because he talks about certain aspects that I totally know, like Kirchhoff's law, but he knows it better than I do. But when you're seeing this, though, when he goes into physics that he's well attuned to, this is where, you have to understand that even me, I'll have to go, okay, I will have to believe him. However, that said, I feel confident that if he gave me all the numbers, or if I go and look at his paper, I can follow his train of thought, and unless he screwed up his math here, we should be okay. And it becomes obvious, but this is not common for lots of people. It's like trying to understand statistics. Something being 100 times more deadlier doesn't mean that 100% of people are going to die. It means it's moved from like 0.1% to 0.2%, or something. It is 100% more deadlier, but still that's a small number to be multiplying. So it's that type of thing where you have to, and it's these type of things where people will misinterpret something and then repeat it. Certain things are really bad for you. Well, yes, but you can put them in your body in an inert way, and it can pass through inertly. Like that's where the chemical reactions come in. Like certain things are really deadly if you put it in your body, but you can coat it with something and it will pass right through. And this is how you can put like heavy metals into your body without turning yourself into a mad friggin' hatter. And I'm not saying go poison yourself or something, but I'm saying that, if you do things right, there's a way to do this but if you think about it, it sounds horrible. Like, oh my God, he's injecting mercury directly into his vein, or aluminum or something. Well, no, it's aluminum bicarbonate. Like, it's basically like no more dangerous than plaque, but because it's inert. But that you can understand why people would get concerned. And so, I try not to make too much fun of people for not knowing that. It's not something that's commonly known. It's like not understanding fission and fusion and just basic chemical reactions.
The interesting thing here is the idea that people can hold two different diametrically opposite ideas as being legitimate with each other, which they cannot exist together. It's just impossible. And yet they still can do that.
But sometimes you have to. Like, and I only mean that in scientific terms. That's common, but not in an ideological sense. Like, you have to hold. Like, I have to hold on to the old theory. Like, Big Bang Theory is still in my head. I mean, it's hard to think that way, but I do. Or if someone gives me two different models of the Saturn theory, I will try to keep them both in my head and to weigh them against each other. As long as time allows, of course.
No, you're trying to compare. They're not trying to compare. Right. They're trying to exclude. See, and it's the idea of data or claims have to be evidence has to be extraordinary for extraordinary claims. That's the thing. That's a lie. The truth doesn't have to be extraordinary. Our perspective might be so screwed up it might look weird or extraordinary, but it's not. The facts are facts, and they're not extraordinary. They just are. And to say that you have to have an extraordinary amount of evidence, or the evidence itself is extraordinary, is a ridiculous idea. And the same thing goes with Occam's razor, where they've twisted it into the point where only instead of assumptions being the thing that you want to have the least of, they said just the least complicated theory has to be the most correct. And then they charged on Quorum, when I was on it, they tried to change that into, well, the oldest assumptions have more validity than the new assumptions.
Why?
I said, no, you can't have assumptions at all.
No, you.
If I could speak.
Go ahead.
Well, see, what's happening here is everybody's feeling different parts of the elephant and saying that it's this, and it feels wrinkly and over here, and then
I'm not telling you which part of the elephant that I have found, but I'm just telling you right now, I have lost my watch.
As we all should, there's no time I mean, anyway. So what I'm trying to say is that we are coming at describing the universe from it's my idea, proprietary. I'm going to disclose it. Approach, and not only is string theory or quantum physics or all of them technically, they're all coming down to saying that these people are wrong, we're right, look at what we're doing over here, even though they're using the other people's math. Then it's distraction after distraction. When it all comes down, what's really strange is that you can see certain models that describe and explain multiple truths and religions in one simple model, and Indra's net is an example, something like an Indra's net, or the network of the Doherty set, or the Doherty networks. These are coming at it from an approach that incorporates what Don Scott's talking about on Birkeland currents,
right?
Also, what Buckminster Fuller's talking about with geometry and manifolds and topological homeomorphisms. And you have to really become interdisciplinary in your approach. You can't start to think that you know anything. You have to just approach it and start seeing that all this stuff starts to fit into certain areas. The areas that it starts to all sort to make sense are the areas that are making some of the times a big deal, but a lot of it's hype and hysteria from the media. So you have to have discernment inside of what's really going on. And ultimately, the only way you can prove something is geometrically. And the only other way you can't prove anything ever. We've all been through this. Yeah. So, but you can prove certain things. And the only way you can prove certain things is only through one of the mathematics. And the only mathematics that comes through that the Freemasons will show as the G in geometry, or the great geometer, the great architect of the universe. I'm not a Freemason and I'm not promoting things, but I'm just saying they have shown that there's, or at least highlighted that there's a direction here. These Colosseums could we and might we look back on these cathedrals in awe and have no idea how they were made because some sort of a catastrophic event could happen, and it would all be secret trades of the Freemasons that have been passed down for decades and eons. Part of the Freemasons, but also architects and other things like that. But I read someone put a text out there or something, but so I digress. That's what I have to say.
Buddy, you were talking, and I had this picture in my head of the Olympic torch, and how they carry the torch from runner to runner, but and then they finally light the the display in the middle of the Colosseum or whatever. But the idea is that everybody has their own torch, but we all share the fire. Like, the fire isn't something that you can own. And I think when we get the idea that, I own the fire and I can now, decide what to do with it, I think we kind of missed the point, that the fire is really something we all share, and it goes from torch to torch. It's sort of, an analogy for information and sort of in
a very real sense, the collaboration between the Soviet Union and the United States was better than the collaboration we have today in many respects.
Well, who knows what we're going to be in a minute here. Who knows what we're going to be in a minute here, but I can tell you what, all of the cybernetics and cyber anything is increasing, and deaths are going down, murders are going down, and everybody's going to come together and say, look at this, look at the numbers. There's 0 murders in Baltimore. There's 0 murders in and so many people are going to come out and say this, and then they're going to say, look at the atmosphere. There's so little CO2. So this is environmentalists who actually have a lot larger of an authority than any of the other polices on the planet, because they protect the people from the land and the land from the people. So if you look at who really has the muscle here, it is the people who are telling you, okay, sorry if it gets political here, but it's the people that are telling you, stop eating meat. We're going to force you to stop eating meat. They're actually, in America, they closed all the 3 largest pork providers. What's really going on here is a lot larger of a thing. And if you read the tenets on the Georgia Guidestones, you can find 100% exactly what they're looking at. That's the eyes. If you want to see what the eyes are looking at and what they're doing.
I'm not trying to convince anyone of any sort of conspiracy ideas here. So
I'm not a conspiracy theorist, but seriously, when you do look at them, you can see verbatim, one after the other, exactly what's going on, along with Plan Agenda 2021. Microsoft,
wouldn't that be kind of like
cyber.
Shouldn't that be pushed forward now that we're already at 2021?
No, we're in 2020. No, we're in 2020. We're not in 2021 yet. Listen, hang on.
No,
2020 is the cybernetics is Microsoft's ID program. It's a fact. You can look it up, and they're gonna. Not only are they they already have all of our audio voices already saved in a vat. All of them. Every single one of our animated personalities, they have saved digitally. Okay, they have your personality, because all of your personality, your personality is the first thing that shows up on Facebook, whether you like it or not. That's your personality, and what you go there's certain things that you go for, and that's your character. What happens is part of your character is what you look at when no one else is looking. So they know us more than we know ourselves based off of analytics. And there's a digital imprint of a person-to-person integration, and they can use it. We already signed off on our digital ID. We signed up. It's not ours. It's not yours. So what they're going to do, and what they can do, I'm sorry, I might hypothesize a little bit, but what they can do with this information is they can make your voice say anything they want it to, because they already have the holograms, and through deep fakes,
I
deep
could
auditory.
probably do that right now with anyone here. I mean, it's not that hard of technology.
Yes. So this is something we don't own. This is something that they own as a hierarchical structure that's called the seventh kingdom. The seventh kingdom is the technium. This is a reality. We live in it. We're contributing to it every day. We should get paid for it, for our content every day.
And China is leading it.
Yeah, instead most of us are feeding it.
I think as much as I don't know why you're so scared of this or how this is related to any of this, but
no, I'm not afraid. I'm just informing.
Well, but I mean, nobody on their right mind would allow that to occur, you know? Like, I mean, China has no choice, but most of us have a choice, and we don't like that. For some reason, some people do.
They'll test the waters and see if we accept it. If we don't accept it, they'll try sometime later.
They'll make us say whatever they want us to say, because they own our digital voice. You don't understand what this means. Look up the rules on digital ID 2020.
Right. But I can just turn it off and not give a shit, right?
No, you can't.
Or what?
You are agreed.
They're going to come and do what to me and my friends here smoking joints?
Okay. This is
Even if you delete your Facebook, even if you stop using your cell phone, they still have your digital record, and
They
can
can
still
have
put
that. Enjoy.
pictures and,
What does this
and
have to do
video
with
of
me?
whatever they want of you doing whatever they think that they want you to do.
They can make you sleeping with a child, is what I'm saying. This is
I'm
very
pretty sure that that can be done anyway right now. Like if I have the right video card, is what I'm saying. Like how is that different than anything I can do, is what I'm saying. Like I can do this, and you can do this. So
okay, good point. Great point, Neil. Good point. Now let me tell you the difference. The difference is you can do it on a small scale. The people who own the content can do it on a large scale and say that you did or didn't do this, whether it's for or against you.
And they will have to prove that in a court of law.
Good luck.
Well, I guess it depends on your laws, but I'm fairly sure that this is not going to be something that's going to be easy to do, you know. And you're talking about like movie level crazy stuff. I mean, don't get me wrong. I think some of it's pretty creepy about some of the stuff I've heard from the NSA. Trust me, I'm kind of creeped out by that. But what you're talking about is an overarching desire, which, again, at the end of the day, when I hear about what's going on, like people refer to globalists over here, and then there's these people who are trying to be like almost anti-globalists, but are also corporations over here, and they're fighting against each other. And then there's a whole whack of like royals and shit and like nations, and they're all organizations, and none of them have the same goals. So what I'm trying to say is, I don't think that I can agree that a monolithic conspiracy, I mean, there might be people who are and I agree, there has to be people that are doing conspiracy, but not everyone is working towards lockstep in the same order, is what I'm saying. So they're conflicting, and this hasn't changed in like literally thousands of years.
Now, what if, which is a book that Bill Gates likes to pick up and show himself with, what if, and this is oh man, I distracted myself.
Well, Bill Gates is obviously has been like I have not been really for. I'm a little bit leery of GMO foods, but basically I'm all for obviously letting less people die. But I've heard so many conspiracy theories regarding him now that I'm almost afraid to even guess at what's real and what's not in some cases, which is disturbing because literally you can't look him up now without, I mean, you have to basically go in the Wayback Machine and try to find stuff posted before the coronavirus stuff. You know, because after that, I mean, he might as well be Satan. You know, like.
I think what you're saying, Neil, is that there's not a lot of economics to back up that kind of activity, and which
people are going to obviously want to make money, but also
well, I mean, who's going to make money off of this? You know, I mean, for specific celebrities and whatnot. I can understand that, but the other thing is that the Masons are not Masons. You have to be somebody who has worked with stone and bricks in order for you to understand the philosophies and all this secret information.
They're incorporated together. You think that the judges and the Masons and the builders and the guilds aren't associated together? They're 5 points. Every fucking guild is 5 point stars. Think about it.
Well, yeah, but they don't know the secrets because they've lost the touch with what the fun. They don't actually know what their secret stuff says anymore. They're lost.
They made up these secrets, these supposed secrets that they hold. The original meaning has been lost to them, and we know that.
How many people care? It's about like us, you know. There's about like maybe a 10th or 28th percentile of, or maybe even 2 percentile of the percentage of population that cares. They don't care. Most of the majority of the people don't care about this stuff.
But there's also things we can change and other things we can't too.
It points right back to geometry every single time. No matter what, it points back to geometry. and
you got to
geometry.
understand that there is also an intrinsic link between geometry and us. Like, we love it.
Oh yeah.
I mean, as human beings, to find secrets in playing with structures and sticks and stuff like that. And I mean, look at Legos. You know, like, I mean, we are really into finding patterns and stuff like that. I mean, it's like the first children's game we get to play with type of thing. Put the square in the right box, type of stuff like that. See you later, Sean.
Well,
sorry about.
If I could just say something about Legos, you know, real quick, just one sentence. The Legos were introduced as more of a male toy, either way, but a lot of the people who are engineers now have said that they were into Legos seriously as children.
I was. Oh my God, so much. I like built entire cities of Lego, and I have the little motors and everything.
So
I can't argue with that.
You know, there's an association with everything. You know, remember when all that other stuff came out, when you could like connect and you could like do metal and erector stuff? Like, that's what's up. Anyway.
It's still a wonderful thing.